So what is a unit circle? It's a circle, first and foremost. It has a radius 1 at the origin or the center. So you're like, well, what's a radius? Let me take you back to those geometry days and remind you that the radius is any distance that comes from the center of the circle to the outside of the circle. And that could be right there. I could also draw a line here because that's coming from the center to the outside of the circle. That distance is 1. So just 1 here. And so I know that this specific circle has an X and Y axes. X, Y. I drew lines in the middle of it because that's how a unit circle looks with the lines. And they're important and I'll tell you right now why. So the very important thing to understand here about the unit circle is that it does only have a radius of 1. And so that means that if I wanted to know this coordinate point right here, this X and Y coordinate point, that point is actually 1, 0, because the distance, again, is only to 1. So then maybe 2 is over here. But the one main important thing to know about the unit circle is that the radius at the origin, coming from the origin, say that weird. The distance is 1. The radius is. Right. So we want to know, though, how does this relate to trig functions? How does that relate to sine, cosine, or tangent? Well, we have already been looking at creating an angle, right, in a circle. So let's say I have this initial line and then this line here. It creates an angle theta here. And we have already been dealing with this in the last few lessons, like what we finding, these angle measurements or finding other measurements. And so how this comes into play is that if this point right here is 1, 0, like I mentioned above, how this helps us out, or how trig functions come into play, is being able to find, for instance, this point here. What is the X and Y coordinates of this point? Now, this is something new and we're going to go over it again in part of the lesson, but this is where the trig functions come into play, because in the last lesson, we were able to find, specific angle measurements or specific lengths. Sorry about that. And so each of these dots are made up of an X and Y, and they are also considered cosine, sine theta. Okay. So the x-axis represents cosine theta. The y-axis represents sine theta. And the tangent theta, we'll get into that in this lesson. But for now, this is where this comes into play. So my next question would be, well, what are the coordinate points of the rest of the circle? So if I was talking about, we know this one for sure. This is 1, 0. If the radius is 1, that means that this is 0, 1, because on my number line, this is 1. Over here, this on my, let's say that we're looking at a number line, this would be -1. If my distance is, if my radius was just 1, and this would also be -1. Nope. This would also be 0, -1. So I know those 4 points for sure. But what about, oh my Lord. Okay. What about if I have this, if I created this angle theta, what about this coordinate point? What's this X and Y? What about this one down here? What's this X and Y? So that's where the unit circle is able to help us out. So let's recall a couple of tables that we've seen in the previous lessons. We first and foremost saw this table here that actually had a lot of solutions, right? When I said find, you're able to find exact values of trig functions. And so we were looking at degrees and radians, and the common ones. So like 30 degrees is if you convert that, that's pi over 6 radians, and so forth and so forth. And if you were dealing with sine, cosine, or tangent, you were able to utilize this table to help you find those solutions. For instance, if I needed to know what the exact value of cosine of 45 degrees is, I would use this table, and this would have been my solution. Now, all of these solutions here, you're going to see this in the unit circle in a second. We'll come back to that. Another thing that was really important was looking here and looking at, well, when you're in quadrant 1, like if you were to graph a specific degree angle measurement, so specific theta, if you land in quadrant 1 or 2, 3, 4, is your solution positive? Is it negative? When is it positive? When is it negative? And we're actually going to see the same positive or negatives in the unit circle. So if I were to have drawn a circle, wow, that's beautiful, circle around this here, I would see like when sine or cosine or tangent is positive and negative. And again, you might not refer back to this, but you might if you're trying to remember how the units. Let's get into this, and let me bring this reminder down that any point here would be, yes, your x and y, but it's also cosine theta common sine theta. So your y is your sine and your x is your cosine. Okay, so with that being said, I wrote it down in words as well. And so you'll see here that sine of theta is the same thing as your y coordinate, and its reciprocal function cosine theta is a reciprocal of y, which would be 1 over y. Whereas your cosine is equal to x, its reciprocal secant is 1 over x. And now finally we get to talk about, well, what about tangent? We talked a lot about sine and cosine, but what about tangent? If you need to know exact trig values of tangent of a specific angle measurement, then your way to find that is by dividing y and x. Now, the thing is, well, we said that y and x can also be represented by sine and cosine. So tangent theta is actually, we can say, which we will have to use from here on out, is tan of theta is y over x. But what is my y? It's sine. So I could say sine theta divided by my x, which is cosine theta. So tangent of theta is equal to sine of whatever sine of theta is and whatever cosine of theta is. Now, we know that, and its reciprocal is x over y. And each of these can never, whatever your denominator is, it can never be 0. But we already know this is the unit circle. Now, if we were in class, I would have presented this circle to you probably with a blank piece of paper, and you fill it in, but we're not in class. So if I were you, I would pause this and write this down. It looks a little overwhelming, but I promise you that it's not. So right now, pause this video, get this down on a paper, and this is like gold. Keep this, make it neat, make it cute, and then come back to this video. Welcome back. So, what's going on in this circle and how to use it? All right. So let's just look at the first quadrant here. As you can see here, we have our 60, our 45, our 30-degree angle. We have our matching converted radians, pi over 6, pi over 4, pi over 3. And we have some version of those on each of these, on each part of each quadrant. So I think I've mentioned that to you before whenever you were graphing, when I was trying to show you how to graph them in radians. But you see here, there's some form of pi over 3, pi over 4, pi over 6, and so on everywhere throughout the circle. And now what you may be wondering is like, how did they get these numbers though? And so those come from that other table, and those have already been calculated for us, and that's a whole other lesson. But let's look at this for a second. Okay. Remind ourselves, for one, that this is x, this is y, and so forth. But it's not just x and y. We said it's cosine theta, sine theta. So what if I want to know what is cosine of 30 degrees? What is cosine of 30 degrees? Okay, so I'm looking here. And I know that cosine, there's too much stuff here. I know that cosine is the very first point here, my coordinate point, because it's x. So this is my cosine of 30 degrees. Let me confirm that with the table up here. Well, let's zoom in. So cosine of 30 degrees, that's square root 3 over 2. Square root 3 over 2. So all these solutions here, those are all the solutions on this table. They're the exact same solutions. But what's different here is, when are they positive? When are they negative in the specific coordinates here? And that's when it changes. And that's all depending on also, like, what if you want to know the cosine of 210 degrees, right? What if you want to know cosine of 210 degrees? That's not on this table. But you could find it using your unit circle. Cosine of 210 degrees. I know cosine is it's the first point of my coordinate point because it's my x value. And so that would be my solution. It's negative square root 3. Okay, so let me try to quickly do a few examples here. Let's start off with sine of pi over 3. What's the exact value of this? So again, I first find that angle measurement pi over 3 on my unit circle. That's here. And then I go to, and I know it's asking for sine. So then I know that sine is whatever the y value is. My y value is square root 3 over 2. So the answer is square root 3 over 2. So pretty straight up, let's do cosine of 135 degrees. So first step again, step 1, find 135 degrees. So step 1, locate 135 degrees. That's here on the second quadrant. This is cosine, so I know cosine is my x value. So I'm going to look at the x value here for this point here, and that's negative square root 2 over 2. Negative square root 2 over 2 is my solution. Third example is, let's do a tangent 270 degrees. So let's first locate the degree measurement, 270 degrees. That's here. That's this point here. And remember that tangent is sine divided by cosine. So the tangent examples always take a little bit longer. But what I'm going to write down is this here. The coordinate point, 0 minus 1. We know that this is cosine, this is sine. Tangent is equal to sine divided by cosine. So I'm just going to plug this in, 270, or substitute this in. So this is negative 1 divided by 0. Now, can we have this 0 in the denominator? No. So that means that the solution is undefined. Now, let's see. Let's do a cosecant example. Cosecant of pi, 5 pi over 6. 5 pi over 6. Now, with these examples, cosecant, let's locate 5 pi over 6. That is here. Now, cosecant is the reciprocal function of who? Of sine. That's here. So, if that's the case, cosecant is the reciprocal function of sine, and sine is my y value. So we see that here, 1/2. So take the reciprocal of that, and that's 2. And that's your solution. All right, I'm going to post the next part, the practice problems, submit these on Schoology, and call it a day. There are your practice problems. Pause this video and write these down. Just be careful here with this one. Remember, when an angle measurement is negative, you want to move clockwise. So if you're going down your unit circle, you'll start here and move and go down this way till you hit 150 degrees. Good luck with that one.